Enterprise blockchain is about more than shared ledgers. It is about trust, control, privacy, and scale across real organizations. In this section, we will look at why Hyperledger Fabric became a leading enterprise framework and how its architecture has evolved. We've already covered the foundations of enterprise blockchain: shared ledgers, trusted participants, and permission networks. Now we'll connect those ideas to Hyperledger Fabric, with a focus on privacy, governance, identity, and control. Businesses often want the benefits of blockchain without the openness of public networks. In enterprise settings, participants are known, identities matter, and sensitive data must be shared selectively. Fabric was designed for that environment. It combines collaboration across organizations with governance, privacy, and modular components for smart contracts, ordering, validation, and the ledger. Think of Hyperledger as an ecosystem, not a single blockchain. It is a Linux Foundation umbrella for projects that support ledgers, identity, interoperability, and developer tooling. Fabric sits within that ecosystem as a ledger framework for enterprise permission networks. Its strength is controlled membership. Organizations know who participates, can define governance rules, and can keep selected transactions private. That makes Fabric a strong fit for consortia and regulated business workflows. The key difference is the trust model. Public blockchains are designed for strangers, so they emphasize open access, broad transparency, and consensus mechanisms such as mining. Fabric is designed for organizations that already have identities, contracts, and rules. Membership is permissioned, data can be shared selectively, and consensus can be chosen to fit the network. Fabric is less about radical openness and more about controlled collaboration across businesses. Fabric works less like a fixed product and more like a set of enterprise building blocks. Modularity lets a network configure components such as identity, consensus, and smart contract execution. Permissioning means every participant is known and authenticated. Confidentiality controls who can see which transactions using channels and private data. Governance ties these pieces together, with policies that define who may endorse, approve, operate, or change the network. That combination makes Fabric adaptable to real business requirements. Instead of relying on mining, Fabric treats consensus as a separate service. Applications first collect endorsements from peers that execute the chain code. The ordering service then places transaction proposals into a single sequence for the ledger. It does not run business logic. After ordering, peers validate the endorsements and commit valid transactions. Because these responsibilities are separated, a network can choose Raft, BFT, or another model that matches its governance and fault tolerance needs. Fabric starts with a simple assumption. Every participant is known. An MSP defines which certificates an organization trusts and what those identities are allowed to do. Certificate authorities usually issue the credentials, but the MSP turns them into membership in the network. From there, policies can define who may endorse transactions, administer channels, or access data. Identity design is not just security plumbing. It shapes governance, compliance, and safe collaboration. Channels allow one Fabric network to support multiple private business contexts. Each channel has its own ledger, smart contract activity, and transaction history, visible only to its member organizations. Org A and Org B can transact privately, while Org B and Org C share a different ledger with no automatic visibility across channels. The goal is not isolation for its own sake. Channels should reflect real confidentiality, governance, and data sharing boundaries. Private data collections handle sensitive details without requiring a separate channel for every case. Actual data, such as pricing, contracts, or personal information, is shared only with authorized peers. Everyone else on the channel sees only a hash committed to the ledger. That hash proves the private data existed and has not changed. The result is confidentiality with auditability, while keeping the workflow simpler to manage. In Fabric, smart contract logic is packaged as chain code. Chain code defines how applications read and update ledger state. Before it can run, organizations install it and approve the same chain code definition, so deployment is not controlled by one party alone. When transactions are invoked, endorsement policies specify which organizations must simulate and sign the results. Only valid, endorsed outcomes are committed. This lifecycle makes upgrades safer because changes require governance before they affect the network. Endorsement policies turn trust agreements into transaction rules. A policy might require both org1 and org2 to endorse a change. Each required peer simulates the proposal, produces the same read-write result, and signs it. Later, validation checks those signatures against the policy before the transaction can commit. If an endorsement is missing, the ledger rejects it. This prevents any single organization from changing shared state on its own. Fabric is not meant to sit apart from the business. Applications use SDKs and gateway services to submit transactions, query ledger state, and hide much of the blockchain complexity from developers. Once transactions commit, Fabric can emit events that feed analytics, alerts, or automated workflows. This makes it practical to connect the ledger with ERP, supply chain, identity, and compliance systems, so blockchain becomes one trusted component inside a larger enterprise architecture. Modern Fabric is less about installing nodes by hand and more about operating a governed platform. Deployment, chain code lifecycle, monitoring, backups, and upgrades should be treated as repeatable processes. External chain code services also fit well with Kubernetes and container-native operations. Just as important, plan compatibility across SDKs, peers, orderers, policies, and chain code before upgrading. The core model remains familiar, but production success depends on automation, observability, security hardening, and a clear path for evolution. Fabric is best understood as an enterprise collaboration framework, modular, permissioned, and governance-aware. Next, we move from the big picture into the core network components that make those capabilities work.